In this video, we solve problem 10.3.56 or 056 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the arc length of the curve on the interval from 0 to 2 pi, and we're given these equations involving theta for x and y. Well, we know that the arc length is given by this formula, the integral from a to b of the square root of x prime of t plus y prime of t, both of them squared, with respect to t. Now, if we're using the variable theta instead of t, we'll have a theta over here, and these will be derivatives with respect to theta. So let's compute those. The derivative of cosine of theta is negative sine of theta, and this part requires the product rule. So I have derivative of the first, which is 1 with respect to theta, times the second, plus the derivative of the second with respect to theta, which is cosine of theta, times the first. And we end up with a sine of theta minus sine of theta, so that's 0. So we've got theta times cosine of theta right there. Similarly, let's find y prime of theta. We've got the derivative of this term, derivative of sine of theta is cosine of theta. And this piece will require the product rule. I'll think of that as my first term and that as my second term, We'll take the derivative of the first term and we'll multiply it by the second. And then we'll add the derivative of the second term. Derivative of cosine is negative sine of theta. And we'll multiply that by the first, which is a negative theta. And so these will reduce, and we'll have this. So we'll have a negative theta times negative sine of theta, which is theta times sine of theta here. Now we're going to have problems anytime that both x prime and y prime are 0, because potentially we might have a cusp in the graph of x and a cusp in the graph of that parametric curve where x is a function of theta and y is a function of theta. Now, the only way that x prime and y prime could both be 0 at the same time is if theta were equal to 0. Fortunately, that's a start point of our interval, so we're not going to have an issue there. So we can just evaluate the integral from 0 to 2 pi of x prime squared plus y prime squared, and that should give us the right thing. So we'll just substitute everything in. Got the integral from 0 to 2 pi of the square root of x prime squared plus y prime squared with respect to theta. And x prime is theta times cosine of theta. And y prime is theta times sine of theta. And when we square those, we end up with theta squared times cosine squared theta here, because you square both factors separately. The same thing happens here. And then you can look at both of these guys and see that they have a theta squared in common. So you can factor that out. And then you're left with a cosine squared of theta plus sine squared of theta. And that's good. We all know that cosine squared plus sine squared is equal to 1. And if we're on the interval from 0 to 2 pi, the square root of theta squared is just theta. We're anti-differentiating with respect to theta, so we'll use the power rule. Add 1 to the exponent. It's going to give us a 2 there, and then we divide by the new exponent, and then we evaluate from 0 to 2 pi. So we'll have 1/2 times 2 pi squared minus 1/2 times 0 squared, which is of course 0. So we end up with 1/2 times that product, which would be 2 squared times pi squared, and the 4 and the 1/2 reduce to give us a 2 pi squared. And that's it. So all we had to do in this case Sorry about that. A little pop-up came up for me while I was making this video. All we had to do in this case was compute x prime and y prime, ensure that they weren't both equal to 0 on this interval from a to b, and they were only both equal to 0 at x equals a, or theta equals a, so that was fine. And then we were able to evaluate this integral, and it was relatively straightforward.